We're going. So I guess whenever you want to start, John, I'd say go ahead.
Okay. Okay, welcome to our weather discussion for today. We've got some interesting things all over the map and all over the country to talk about today. None of them particularly high profile, except for one issue, I think. And then I don't want to step on the toes of the forecast discussion, but I'm going to say one thing that I noticed over the last couple of days in the tropical West Pacific, just for a split second at the end. So that's kind of what I'm thinking of talking about in my discussion. So let's begin by looking at the satellite movie over the continental 48 states and the adjacent waters. And there's a lot of action here. There's a really intense cyclone that's circulating out to the south and east of the Canadian Maritime provinces. And you'll notice one of the curious characteristics of this is that it seems to be just a collection of open cellular convective storms. And we'll see at 500 millibars whether or not it's particularly cold at upper levels over this. I bet it is. And this is about where the Gulf Stream's heading out. It's at the right latitude for the Gulf Stream heading out into the central Atlantic. So that might be one of the reasons why it has that complexion today. We'll put 2 and 2 together and see if that's not the case. Then, of course, we have the first rain of the already extremely warm month of April. We're running at 12.3 degrees above normal for this month so far. And it's about to be depressed a little bit naturally, but still really exceptional warmth. We had 79 degrees on the 6th and 78 the day before. So almost 2 days at 80 together. And Michael had made a comment to me earlier this week about a dew point nearly at 60 degrees. When in fact, I think we exceeded a 60 dew point at some point during that stretch. I don't know. I couldn't find on that fabulous Scott Lindstrom sent website to me some years ago. I couldn't find a place to look for the earliest 60-degree dew point in Madison's history. So I don't know what that was. What's the earliest time it's ever been 60 here? But maybe we had one close to that in that March of 2012 when we had 5 days over 80. So I don't know if we set the all-time record or even came near it, but it certainly was muggy for the first time all year in the last week. But now,
John,
yeah.
Just we have a comment in the chat. Ben says Minneapolis, Minnesota broke their daily record by 5 degrees on April 5th. They hit 85.
Oh, is that right?
Yep.
Yeah, we were only 78 here on the 5th, so they got better than us. That's amazing. And so their prior record was only 80. So yeah, we were close to the regional sort of highest temperatures that we've seen, but not quite there. That's amazing. But dew points over at or over 60, I don't know the record on that. That's a very interesting question, and I wonder if we didn't kind of set it. It's easy to forget it was only the first week of April that we were just through, and last year and the year before, actually, in the middle of April, we had measurable snow. So we're not done climatologically, but I think we may be done meteorologically this year. It doesn't look like that's in the offing. I hope that's the case. But it did rain finally, as I was getting to. We had 0.12 inches on 3 days ago and then 0.38 yesterday. So we have a ½ inch of rain for the month of April, which is almost 3/4 of an inch. I mean, a 1/4 of an inch below normal. So traditional April showers are only now beginning, and we're just a little bit behind for the month. But this disturbance that's sitting on top of us right now may cure that over the next couple of days. I think we've got a pretty good chance at that. And it's a beautiful cyclonic disturbance. I mean, it presents itself sort of centered straight in the middle of the continent. And its southern periphery has some convection over the panhandle of Florida, Georgia, and parts of Mississippi and Alabama. And then a little bit, I'll have a close-up of what's going on over the Red River Valley into, straddling parts of Oklahoma, Arkansas, and Texas in just a minute. Over the western United States, pretty clear. Region of high pressure is built in through the Pacific Northwest now into the Intermountain West. And there's a pretty nice cyclone that's just made landfall on the coast of British Columbia. Associated with it is a really intense upper front, which I'll just comment for a moment on the structure of that when we get there. Before we leave this image, though, we really do have to go down to the Caribbean, to the island of St. Vincent, where the La Soufriere volcano has gone off. And right where the cursor is, you'll notice just before the clouds come in off of the continent, you see that little puff. That is the explosion of the volcano. Right there is where you see it. So that's pretty neat. If it hadn't happened at that moment of clearing, you wouldn't even notice it, because that puff, dramatic as it may have been to be there and see it happen, looks like nothing on this gigantic satellite image. So, but there it is. There's the eruption in St. Vincent of La Soufriere. And so that's a pretty neat event. Okay, so let's keep on going to just an overview of the sea level pressure field. This is from the Gfs Analysis this morning at 12Z. And we've got the cyclone off the Canadian Maritimes. Notice in the thickness field, the yellow dash lines here, there isn't an obvious frontal structure left to this thing. It's just kind of devolved. It's been there for much of this week, as it turns out. I've mentioned it a couple of times in my 100 class. So the thermal structure is kind of not really so obvious anymore, at least in the 1,500 millibar thickness. And our cyclone sitting just about over us, actually probably right over La Crosse, is equivalent barotropic. We'll see in a minute when we go to 500 millibars, and you can even see a cutoff 540 thickness line sitting there. So relatively chilly air aloft, and that probably is a harbinger for continued cloudiness and maybe even continued shower activity. We're entering into that part of the season where cold aloft with high sun angle can mean showery weather. And so I think that's why April showers bring May flowers. I mean, we're kind of tied into that. And here's the cyclone that's made landfall into British Columbia. You can see the strong thickness contrast out over the Gulf of Alaska. That's where the upper front is. We'll look at a cross section of that in just a minute. And that storm is kind of getting ripped apart by the high terrain along the coast of British Columbia. So it won't really be a major rain producing event for the Pacific Northwest, at least not for the next day or two. Okay. Then the radar summary over the continental United States is in some places quite dramatic. You can see the convective activity over the panhandles of Florida, Georgia, Alabama, and just off the Gulf Coast of Alabama. A couple of places where the reflectivity is quite high, probably hailstones coated with water or something like that. So that's pretty intense. And then you can see a blow up right here in southeastern Oklahoma and southwestern Arkansas, which is pretty obvious as well and looks menacing. And then the precipitation is scattered over the western Great Lakes region. We've had maybe a couple of little drizzle showers this morning. It's been a little bit more intense over central and eastern Minnesota. And so I think as this cutoff kind of gradually sags to the south and east, we may see some more of that before the main event tomorrow. But here's the, I want to show a little bit of a close-up from the visible of that blow up over southeastern Oklahoma in the next image. So it's quite a dramatic 5-minute imagery, or maybe it's 1-minute imagery, but it's beautiful. You can see how these things are just exploding over the south of the Ozarks and in Missouri and Arkansas and over southeastern Oklahoma. So that's kind of an impressive region of convection. And I wonder what the wind direction is over Louisiana. Pretty obvious. You've got these probably wind parallel bands of cumulus clouds giving you a really nice view of what the winds look like over the state. So that's kind of nice. And the air is quite humid too. Dew points down along the Texas and Louisiana Gulf Coast are at or just above 70. So this is really juicy air. And I think the dew points even as far north as southern Arkansas are in the low to mid 60s. So it's a pretty potent air mass down there. Okay, let's now go to the West Coast satellite image and get a look at the storm that I mentioned crashing into the northern coast of British Columbia. And you can see it's got a very obvious comma shape, even when it's kind of, most of the clouds are in the Yukon and Northwest Territories. So that's somewhat unusual to see such a nicely depicted cyclone in the satellite, but you can see how it gets raked by the high terrain in British Columbia. And it's right in this region here where you see open cellular convection. You know the air is cold. That's the cold side of the upper baroclinic zone that I'll give you a little tour of here in a minute. And one even gets the idea that the winds are quite strong. You see these little puffs of clouds moving straight across on the southern edge of that baroclinic zone at a pretty high clip. Unfortunately, we get a little interference there, but you can see them scooting along. Here's the state of Hawaii. So we've got a nice, almost stationary disturbance. It's been there for a couple of days, sitting to the north and east of our 50th state, and that's mostly open cellular convection as well. There's a better looking, better organized storm in the central Bering Sea that is got a cold core right there. You can see coming across the Aleutians. And then there's one more disturbance that's just about at the boundary of the tropics and extratropics. That's just a collection of convective cells that are kind of getting themselves organized just to the west of the date line at about 23 or so degrees north, as you can see in the satellite movie there. So that's the depiction of what's going on across the Pacific Basin. It's been a relatively boring week for the Eastern and Central Pacific Basin in terms of well-organized storms. The one feature of some interest, but it won't have blasting interest, is just this cold upper trough that's coming across in the southern Gulf of Alaska. So let's go now to the 500 millibar map that's from this morning. This is the super peak. And first, I'll draw our attention to the cyclone that's right over us or over La Crosse. And the temperature in the center of this thing is about minus 21. You got 3 observations, one at Davenport, one at Green Bay, one near Minneapolis, minus 21 degrees C. So it might be a little colder in the middle. So that's, relatively cold. It's plus 10 at the surface, around 50 or so. So you've got a 30-degree temperature difference over 5 kilometers. It's just about moist neutral, or maybe a little bit less than that. So that probably explains the persistence of the showers. If it were just a little bit colder, we might have more widespread showery activity. And that maybe is in the offing with you've got air that's at minus 30 here over Wyoming and Montana that's likely to swing in during the day tomorrow. So that's the feature that's been giving us the rain, the half-inch or so of rain we've had over the last couple of days. Downstream of it, there's a big ridge that goes all the way up through the northern part of Hudson Bay. The weather is clear on the east coast of the United States today. And then here's the cutoff cyclone to the southeast of the Maritimes. And you can see, again, it's not very cold aloft in that minus 22.4, and the ocean temperature is maybe about 10 or 15 C. So that it's not the coldest air, but the Gulf Stream temperature was a little bit warmer perhaps than our surface temperature, and that might account for the slight increase in density of those of the distribution of those convective elements that are associated with it. Here's the really interesting feature to me: a very strong baroclinic zone. It's as warm as minus 16.6 on the warm side of this, and as cold as mid minus 30s, actually minus 37 right there on the north coast of British Columbia. So much of that temperature contrast is contained in this very stubby, very narrow, I should say, baroclinic zone. An 80 knot wind here at Nanaimo and 40 knots further to the north. So there's a really strong horizontal shear as well. There's some cold advection in that cyclonic shear, geostrophic cold advection that one can articulate out of these maps. So that's a pretty nice upper front. One also notices that this isentrope here, the minus 15 or minus 20 isotherm, has this weird jag into the gradient, and then it comes back out and slacks off from the gradient. That's indicative of subsidence going on here to make this air relatively warm in this little chunk. So I'm going to show you a cross section through that in just a minute. So that's the interesting feature at 500 millibars. Michael and I think Greg were talking a little bit about how the tropics sometimes need to come in and kick up the extra tropics and all this nonsense that they like to spout. I just want to show you something John. Look at this map at 300 millibars today, April 9th. That is a polar jet. Please don't tell me that that's a subtropical jet that somehow, got itself kicked up out of the low latitudes and made its way across Alaska. Here's your straggling wind speeds in the subtropics, which will suddenly become intense when you go to higher elevation, like 200 millibars. Now we're talking about a really robust subtropical jet, and this feature fades away. So this is a clear case where these are separate features. I didn't. The orientation's not quite right. Would have been nice to draw, maybe tomorrow will be a good time to do this, to draw a cross section right through the polar jet will make its way through southern British Columbia and Saskatchewan tomorrow. And the subtropical jet will still be roaring across California and Arizona. I think it'll be nice to draw a cross section through there to show how distinct these features are in this particular instance. And I'm only mostly joking here, but I have to put up a little bit of a front for the extratropics. They do have a lot to say about our sensible weather. It seems ridiculous that I have to say that, but I'm
putting up a front, John. So that's a nice pun.
That's
a nice pun.
What?
That's a nice pun, putting up a front.
Yeah, that's true. So this is a really strong polar jet, and it's rather isolated. It's got all by itself. So it's an interesting feature. So mostly in jest, but not entirely in jest. I do want to show you this. This is 12Z from the GFS this morning. So unfortunately, you can't see the isotherms on this map, the inset, but I'm cutting a cross section across the southeastern Gulf of Alaska into the Central Pacific. So that's meant to show you a cross section roughly along a line like this, kind of right through the upper front. So that's what I'm trying to show you. And here's the PV structure. This dashed line is the 2 PVU contour. And then the isotaxer here got 130 knot wind at about 300 millibars. And not only a upper tropospheric front associated with the downward protrusion of the high PV from the stratosphere, but a really nice lower stratospheric front as well. So this This is a maw, sort of a gaping open jaw of isotropes right around the jet. So you've got a front in the lower stratosphere as well as in the upper troposphere. And so that's kind of an interesting feature. I'll leave it to the forecast to trace, if they do, to trace where this thing goes. But it's a pretty intense upper vortex feature right now at 500 millibars. And it remains so for a while, but it does not appear anyway to really have much of an influence on downstream weather. I think there might be a recession of the tropopause level PV as soon as the temperature advection along the jet changes to warm advection. You start to push things back to where they belong at high elevation. So that's what it looks like is about to happen in that thing in a day or two. So one last thing I wanted to show you, and I hope I'm not stepping on Kari's toes on this, but this is the Western Pacific from Tropical Tidbits from the GFS. I'm just going to run you through this. Watch what happens to the southeast of the Philippines. This is a 1,009 millibar low. And one sees a sort of an aggregation of convective elements in the forecast. And then it's, well, what's going on? 998, 986, 89, and here we go, tropical cyclogenesis. And you get this really intense tropical cyclone by about 18Z Monday, 913 millibars at the center, well to the east of the Philippines. And it has exhaust of some of its water vapor and cloud masses heading out into this disturbance that's to the northeast of Japan. This particular tropical storm, quite intense, does not ever seem to really perturb the jet field a lot. But that might just be a little bit wrong in the forecast. And it might also be that it's just not quite close enough. And this is a pretty intense anticyclonic gyre. So one imagines perhaps some of the outflow just gets caught in this gyre. But it does, I want to show you a cross section through this jet, just to give you an idea of what we're dealing with. And I'll go all the way down here, so I might be able to catch some of the outflow as best as we can catch it in this cross section of PV. I really wish instead of color coding, they were actual values, because these colors, this dark blue is like -1 PVU. So this is really low potential vorticity. And I suspect a large chunk of this region, which if you remember is going to be right about here in the cross section, is going to be outflow from this extraordinary tropical cyclone. And so you get a big plume of low PV that banks up on the anticyclonic shear side of the jet and creates this kind of wall of high PV between the tropics and the extratropics, and a wind speed maxima here of about 190 knots in the center of that thing at 200 millibars. So it's going to be an interesting feature to watch if it turns out to actually develop. And it's only a week away. So it's going to be really interesting to see if that happens. I was on the phone last night with Greg and Michael about the frequency of tropical cyclones in the West Pacific in April. And I guess it's not unheard of at all, but it's really not their peak season. Anybody knows that. And this thing is a pretty intense example of a tropical cyclone in early April in the Western Pacific. So it's going to have ramifications on the jet. I don't know if those ramifications are going to be of the kind that spawn downstream forecast problems in that week, let's say 15th of April to 25th of April or something like that. I have a feeling this one might not quite connect the way that others, historical examples, have connected and really screwed things up over the rest of the Pacific and North America. So that is something we'll have to wait and see.
Hey, John.
Yeah.
So, this tropical cyclone season in the West Pacific is almost throughout the year. I mean, obviously for the Atlantic Basin, it's, June through November, and for the Pacific, May, mid-May through the end of November. When's the extratropical cyclone season in terms of the interesting ones?
All year long. You
November
probably, yeah, like the one that's over us right now. That's interesting. And things that have come as early as October or late September are really interesting. So I'd say it's pretty much all year round. One maybe has a respite from them in June and July in our location, but that gives you time to do research. So it's perfect timing.
Okay. All right.
I'm sorry. Was there something behind that question beyond what the actual question was?
I think it would be more like November through April, maybe are the interesting ones.
Yeah. I don't think that's correct. And I think you know that. So that's fair enough.
Okay.
But an excellent question. Thank you for the platform. So one last thing about the low PV. Look at how the ice attacks are all completely discombobulated in this region. So and look at the stability is really weak at 200 to 300 millibars in this region. So this might be where the air is actually leaving the tropical cyclone and exhausting into these. This is only a 10 Kelvin layer that spans more than 150 millibars. That's where all the outflow is going from 345 to 355. And it's really screwing up the PV. So as I say, I would contour this instead of color code it. I think it's easier to see in that case. I know Greg does that with his Vis 5D maps, and that's a better way to do it. You can really see the slug of low PV. So anyway, this will be a fun thing to watch as the week goes on.
John,
that's all I have.
John, I had a quick serious question.
Yeah.
Was if we go back to the plan view, the horizontal maps, at the
Of
surface.
This one here. Okay.
Yeah, so close that out. I was curious, are there any other developments? Because once you get that nice sprawling anticyclone in the upper troposphere, that kind of makes it conducive for maybe future developments. So that's one of the ideas that Greg and I and Zoe have been kind of kicking around a little bit, is that often one tropical cyclone, its outflow creates an environment that might be favorable for future ones.
Yeah, so let's watch this.
Later.
Let's watch this thing down to the south and east. I believe that it does develop, so we'll keep going forward. It surely does. It gets to 994, and I think that turns into something a little more impressive. 997 is the end of the forecast. I believe in one that I saw last night, this thing became a little bit more impressive than it has in this more recent forecast. So there does seem to be some sort of development to the south. And if this is at latitude, 10 or 11 degrees, the pressures are never at 977 at those latitudes. So this is another tropical cyclone, not apparently in this forecast, not quite as intense as its predecessor, but looking like it's got a chance to have the same sort of life cycle, perhaps with a lesser intensity. Sorry.
Right.
Yeah. So that's something to watch out for too.
Interesting. All right. Thank you.
Okay. I'm going to stop sharing.
Okay, I think it's my turn now. I'm gonna share my screen. Okay. Are you seeing my screen right now, or?
Yes.
Okay, perfect. So I'm gonna start with this weather outlook over here. This is valid for the next 34 hours. So we are gonna expect moderate and enhanced and slight and marginal risks mostly on the southern part of the U.S. for tonight and tomorrow morning. So the question here: what are the conditions that are contributing to this formation of severe weather over these regions? So to start answering this question, let's just first look at 300 millibars. So looking the GFS initialized at today at 06 UTC. We are going to see the evolution of the polar and the subtropical jet that John mentioned before. It's interesting because they are two separate and we can observe in the evolution here. So we are seeing like the upper trough. Sorry, my computer is a little slow. Okay, bad timing to be freezing, but okay, so now it's working. So when we are seeing the upper level trough over here that is developing in the central of US, and here. So this is by tomorrow morning we will have this upper level trough moving to the central of US, and we have the intense of wind speeds in the downstream region of the trough. And this is I would say the polar jets, and we down here we are seeing the subtropical jet that is also moving through the southern regions of US. So as we're moving forward in time, we continue seeing the evolution of this upper level trough and how the subtropical jet is moving through this the southern eastern of US through the weekend. So now looking at mid levels, we are gonna observe again the GFS model initialized at the same today at 06 UTC. And we are seeing a mid-level trough that is starting also developing in the center of US. My computer is okay. So let me just wait. Okay, so now this person. Shear. Okay. Oops. Okay, so seeing the evolution of the mid-level trough, we are seeing that is forming in the center of US by tonight, and tomorrow morning it will be continue moving to the northeast region. And so one interesting thing to observe here, I know that it's freezing, but just the moving of this upper trough that we observe here, mid-level trough. And one thing, an important point to observe here is that we are seeing a lot of westerly winds that is moving mostly dry air into the region of the southern east of US. That I'm going to mention later why this is important. So now looking at so now looking at lower levels at 815 millibars. Again, GFS the same time, and it's initialized for the same time. So we are gonna see the evolution of this low sulfur pressure that is induced by the mid-level trough. And what a lot of things we can observe in this image, because we can observe how the sulfur pressure is just moving to the southern east of US and the northeast of US. In addition, when this start working correctly, we're gonna see we can distinguish the cold front that is moving through the region. In addition, I think I can take here. Okay. So this sulfur low pressure that we're observing here is the one that is affecting us for the last couple of hours or days. So after that, we will observing that by tonight and tomorrow morning, we have another sulfur pressure that it will be forming across the region that is over here. So one thing that we can observe here, we are seeing a warm and moist air, warm advection that is moving through the southern states over here and through the northeast part. And also we are also observing the cold and northerly winds that is impacting the Midwest. Also this cold front over here, this cold temperature and northerly winds, it will be causing a slight decrease in temperature in the Midwest, that reaching maybe just the 50 degrees. It's not like a huge decrease in temperature, but it will be changed a little bit compared with the last weekend. So another thing to mention here, that with the pass of this cold front, it will be producing gusty winds near the front and behind the front. So it will be producing a large winds in the southern states over here. So now just let's compare another image here. Also, we are observing here theta E. So we are going to see the evolution. So right now, I'm not going to touch it because it's working perfectly. So right now we are seeing a lot of positive buoyant air and stable conditions and high moisture content in the southern states that we observe here. Also, we can see the contrast in temperature. We are observing also dry air to the west. So this dry air compared with the moist air to this area, we can then, and also because of the direction of the wind, we can draw a dry line over here, as I'm pointing here with the mouse. So these dry lines, we mentioned in class, is one of them initiate the convections in this area. So we have another feature that it will contribute into severe weather to the southern states of US. So now let's just go ahead and take a look to this sulfur low pressure. No, my bad. Let's take a look about the cave. This is again GFS initial at the same time for 06 UDC. So one interesting thing about the cave is that we can observe the evolution on how this instability start increasing in the southern states. And by tonight and tomorrow morning, we're gonna see a large increase in instability across this region, especially for Mississippi, Louisiana, and part of Texas. Now it's freezing, but I will wait a little bit because I want to show you that it's really impressive how the cave is starting increases over that region by tonight and tomorrow morning. So we see really a large instability in this region, causing us again for the moist and warm air that is moving through the region, interacting with the mass of cold air. Now let's take a look then to the evolution of this sulfur low pressure and the precipitation rate that we're going to expect for the next following 24 hours and 36 maybe. Again, this is the GFS model initialized at the same time. So we are seeing here, I'm gonna mention this is the low pressure that we'll be observing that is forming here, mostly a little south where I'm pointing my mouse. So this is the low pressure that will be moving through the Great Lakes, and we're leaving great precipitation rates along the cold front. So I'm gonna get back on time. So let's just see the evolution of this sulfur low pressure. So we are seeing this is the one that is affecting us right now. And here is the sulfur low pressure that we are starting developing, and it will be affecting the southern states. So we can see the large spread of precipitation, especially affecting Alabama, part of Mississippi, and Louisiana. So we are seeing really large precipitation rates over the region, caused by this cold front that is moving through there. So now let's just compare different models just to see how consistent they are. So we are seeing here for the same time, again, inshallah at the same time. Well, actually it changed because we changed time, but it's initially at the 12 UTC. And we are going to compare the GFS. So right now we are seeing this is the low pressure that will be moving to the northeast to the Great, or to the, will be moving to Great Lakes. So this we can see the large spread of precipitation across the area that is moving over there. So when we compare the same, but at the same time, different model, again, let's just take a NAM, 3 kilometers. So for the same time, we are seeing that there seems to be consistent with the moving or the location of the storm, but the precipitation rates change a little bit. We are seeing more broad structural precipitation across the states in the East Coast with the global model, but we are not observing the same with the mesoscale model, with the NAM model. So we are seeing consistency, but not in the location, but not with the precipitation rates. So now just take a look to
Kari, I have a question real quick while you're on this. So this time is for Sunday. You're talking about the disagreement.
I can go back to it in time just to show how this super low pressure is intensifying with time. So I just compare with the model too. Yeah, and it's just the internet is a little bad right now.
Okay. Yeah, I was curious how it was doing a little bit earlier on with the storms to the south. That's what I was asking for. Yeah, thanks.
Yeah, but yeah, when you let's compare with this time. This is initially at 12 UTC today. So comparing 24 hours for 24 hours from now, this would be Saturday, or I would say mostly by tonight. So this is the NAM. We are seeing like really high precipitations and really intensity, reflectivity over here. So that means that we will have intense activities through those states over here, especially Mississippi, Louisiana, and Arkansas. So when we compare, let's compare this time with a different model, with the GFS, with the global model. The same time, we are seeing a different structure, and definitely different precipitation rates across the states. So it's different a little bit, but they're consistent, I would say, with expected activity, precipitation activity in the region. So when we move, let's just move by tomorrow morning, a little bit ahead of time. So, okay.
Maybe if you turn your camera off, that might help with some bandwidth.
I will try that. So, okay, I was here. Let's just try one more time. So yeah, let's see the evolution. This would be later by, let's just compare by tomorrow morning. We are seeing this for the GFS. Let's just compare another model over here. So let's compare again the NAM 3 kilometers. So we are seeing the, the precipitation rate along the cold front that is moving through the region. So it's consistent with the location of this low pressure. I would say more intensity precipitation rates with the NAM compared with the global model. Let's just move a little bit by tomorrow evening just to see where this low system is just moving. So a little bit ahead of time. So yeah, I like to show this one that is mostly Sunday morning, because when we compare this forecast for this is the NAM 3 kilometer, we are not seeing precipitation in this region. But when we compare the GFS by this time, we are seeing precipitation rates. So I think the model start having discrepancies with time, especially in this with the precipitation along the state in the East Coast. So now I just want to show the cross section for this cold front. So here I'm just showing here at the bottom, this is the cross section that I just put here from A to B. So this is from A to B here, from A to B. So these high winds that we are observing here, the colors represent the wind speed. So the wind speed that we are observing here, this part in particular, the one that I'm pointing out, is the polar jets. And one interesting thing to observe here is that we can observe the two jet streams here. This one over here that I'm pointing now is the jet stream. And also we are seeing the small slope over here that I'm pointing here. So this is the cold front that is moving through the region. So there will be a more unstable and conditions to the ahead of the cold front and more stable and cool air behind the front. So I just did a different cross section from the same similar region just to compare how they changed. So these are different, this A, B here that I'm pointing right now. So this cross section we see a similar behavior. This is the polar jet, this is the subtropical jet over here, and more unstable air, but there's not that strong over this region, and we are seeing the slope, so representing the movement of this cold front over the area. So again, this is different, just moving a little bit the cross section, but it's just showing the similar behavior over there. So I just going back to the beginning, right? So I mentioned that we're gonna have moderate, enhanced, and slight risks over the southern states. But why is that? We mentioned different conditions that are favorable for that. For example, let's just start with the first one. For tornado, we had 10% for Mississippi, Arkansas, and Louisiana, and 5% for states including Oklahoma, part of Texas, and Alabama. So what are the conditions that we observe in the model? We observe that we're going to have wind shear because we will have at the low level, we have southerly winds coming from the Gulf of Mexico, and we will have westerly wind in the mid levels. So we have right there wind shear that will be present. We have instability that we we've been moving through the area, creating over the area. I have showed with the GFS a model that is produced in the Cape over this particular region. We also mentioned all the moisture that's moving through the region that's coming from the Gulf of Mexico. And also we mentioned the lift mechanism that is contributing to this formation of tornado across the region. So for winds, we're gonna have higher probability. We have 45% for Mississippi and 30% for the state, including, in addition of Mississippi, including Arkansas, Louisiana, part of Oklahoma, and Alabama, and 50% including part of Texas and Georgia. And when we mentioned we're gonna have the probability to have large winds or damage wind over the region, that will be mostly brought by the movement of this cold front that is moving through the regions that is causing these gusty winds as they move over there. So another things that for hail, for example, the probability for hail, we will have 30%, especially for the northern of Louisiana and southern of Arkansas and part of Oklahoma and part of Texas, and 15% including state of Alabama and Georgia, and 5% including other states like South Carolina, Mississippi, Missouri, and most large area in Texas. So what are the conditions that we observe that will contribute to the production of hail? We also observe we have the strong updraft that will be moving to the region. This strong updraft will be creating a good condition to move these embryos high above the freezing level. So it will contribute to the hailstone growth. Also, we have dry air at mid level that also contribute to the hailstone growth. And we will have another characteristic of the hailstone that is the strong the wind shear, that the wind shear is also another condition that contribute to the hailstone growth, because avoid or didn't allow that these embryos are blown out of the storm. So it contributes to the hailstone growth on this thunderstorm that will be developing over that regions. So I think after the moving through of this cold front through the Great Lakes and moving through the Northeast, we're gonna start seeing more clear condition and fair condition to this part of US, mostly for the Midwest and Northeast. And maybe by the mid of the next week, Wednesday, we start going to see more instability across the region again. And that will be all. I don't know if you have any other question.
Thanks, Kari. I want to open it up to everyone online if anyone has questions for Kari. We've got plenty of time. I'll get it started and see if anyone else has. Oh, go ahead, Michael. Go ahead.
Right. Just a quick question. With the probability of, or the concern about tornadoes, is beyond tornadoes, is there, could you distinguish between those and maybe just a squall line type of weather event developing? What makes it particularly, this situation particularly relevant for tornadoes versus perhaps a squall line forming? Sort of linear band of convection.
Yeah, I think it's because of I wouldn't be 100% sure about that, but I would say because of the formation of the sulfur low pressure, the structure of that will be contributing to it's just the interaction between the cold front and this Gulf warm air from the Gulf of Mexico that I think it will be in even to spread into a line convection, but I don't think that I can say much there.
Okay.
Kari, my question for you, I'm just trying to put the timing of these pieces together, because one of the things John showed this morning was, you know, some of the convection already kind of firing up over off the Gulf Coast and then in East Texas. So you had mentioned a couple different kind of initiation mechanisms. And I'm curious, you know, you're talking about the cold front and kind of the squall line feature. It seemed like that was more overnight. And I was just wondering if you could speak a little bit more about the conditions favorable for maybe what's going on right now. I know you probably didn't look at exactly what's happening now when you were putting this forecast together, but I was curious if you could maybe talk a little bit about that based on the conditions you showed before. And I don't know if there's any soundings that you can access, or even if it's in the model space, if you could talk a little bit more about that.
Yeah, about the conditions that are happening right now is just due to a cold front or a surface level pressure that is moving. I think that I show maybe this is 5 millibars. So if I show here the A50, no, this one. Here, so right now this is the surface low pressure that we are having right now, and this is the low pressure that is having more instability across the region that was causing the rains that happened through the Midwest. So that's the one that was causing the severe weather actually last night too, because the interaction of this with these two masses of air and the warm and moist coming from the Gulf of Mexico interacting there. So that would be my guess of what happened last night. And then for you mentioned the SQ2, I was planning to show the SQ2 for the regions, especially Mississippi. That is one of the have the larger probability of hail and tornadoes. And so I just show here. So yeah, this would be for, I can go back a little bit on time for the time that we are. This is tomorrow morning. So let's just pick get the sounding for Mississippi. So when we point over here just to see how the soundings look like for that time, we're gonna see this is not a good time. So sorry, I just got lost with the time. So this one is by tomorrow morning tonight. So just I will always say here, this is not the best example, but it's just yesterday the schedule looks a little bit different. When we have more dry air in the mid level, but also we have moisture content at the surface level. So we still have a updraft over here at the mid levels of upper levels, but I think this is not the best example for severe weather at this region. So I just want to see if we can have a good example of severe weather. I think maybe this one is much better, but
what about Kari, the forecast sounding for maybe 0Z today? Just kind of curious, like as instead of like going into the morning, I'm just, you know, if we take a look at the 12Z sounding, there's a really substantial stable layer near the surface. I'm just curious what the forecast sounding thinks going to happen by 0Z.
So you say for
maybe that would help.
For
yeah.
Right now.
Huh?
You say for the schedule now like.
Sorry, maybe about 0Z.
06 for today.
0, perhaps. I'm
I'm
not
just-
sure how hard. Yeah, this looks like it goes.
Yeah, I'm trying to. Yeah, this is the for 12 UTC. So
That was this morning, right?
yeah. Mhm.
Okay.
So I can click Mississippi again and get this. So yeah, there is not a lot of cape this morning. So I think because they're trying to their thunderstorm will start developing through this evening until tonight. So the cave is still not like strong over the region.
Does it evolve much throughout the day? And then I see there's a question from Brad. Just curious, since you have the freedom with the model to kind of look at its evolution throughout the day.
Yeah,
If you see.
definitely this. Yeah, this is the one that I was trying. This is
there you go.
Yeah, later on in the afternoon. So we are seeing more large cave and on the moisture at the top of the PBO. We also been seeing wind shear to the layer that also contribute to the instability and the severe weather production in there. So yeah, I don't know who asked first, but
Yeah, we'll go with Brad. He had his hand up first.
So I was looking at the current infrared satellite data, and it's interesting. It looks like the first convection that's firing up is actually over the Gulf. And I'm wondering whether that there does appear to be a lot of moisture convergence in that region, or is it that the sea surface temperatures are warm enough? It might be interesting to look at a sounding now that's over the Gulf and see what it looks like.
yeah, you can observe the sounding for the Gulf.
Still real close to the shoreline, but you know, yeah, like maybe right there somewhere.
So yeah, we observing cave and wind shear too, but dry air, I would say from the lower levels, we are not seeing moist. I mean, there's moist, but there's not like high content of moist.
Thanks.
Yeah, John.
Yeah, I don't know how good the models are now at representing soundings, but I know when I was doing research on these squall lines in the Southeast in the late 80s, it was the NGM that we had. It was our only option. And they were routinely too dry in the boundary layer. So Brad's point's a good one. I would be surprised if that's really that dry over the Gulf of Mexico, at least in the lowest 100 millibars. Maybe it is, maybe it isn't. And that would change the complexion. Every one of the soundings I've seen, though, Kari, is really got an interesting characteristic. Slight backing of the winds right around 500 millibars. And that really makes me wonder if there isn't some sort of disjointed vertical structure in this whole environment that's leading to some locations fairly intense and in other locations fairly minimal cold advection sitting on top of this warm moist advection that's coming in off the Gulf of Mexico. And the disjointed nature of it is really driven home to me when I look at a 30-hour forecast from this morning's GFS of the 850 millibar thermal structure with the geopotential height. If you happen to take a look, and I'm not suggesting you do it now, but anybody who takes a look, you'll see the baroclinic zone that finally gets itself consolidated and is the front that I think you've been talking about, along which some of this stuff fires up, is well to the west of the geopotential height trough, and the winds are just cutting across it. It's almost like one of these weird low-level temperature features that occurs in Oklahoma, but this is all the way into Arkansas and northern Louisiana. So there's something that doesn't quite seem all 100% structured, almost like the Hobbs et al. Cold frontal loft structures, but it doesn't, there aren't enough signals in the data that make me think that's what it is. It's just that it doesn't have a really coherent structure thermally and frontally in the vertical. And I'm wondering if there's something funny about some of these early spring outbreaks that can sometimes have that characteristic. I don't know if I really have a question there that you have to answer. I'm just kind of pointing it out. But even in the sounding you're showing right now, look at that little bit of backing of the winds around 500 millibars. And some of the other ones you showed, indicative of cold advection in the middle troposphere. That's certainly going to destabilize the environment, even if there isn't really any particularly strong forcing at the ground.
All right, it's taking me forever to unmute. Do we have any other questions for Kari? I just posted a link to, well, a surface map from 15Z that highlights some of the features that Kari was talking about in the forecast to kind of see what's going on this morning. So you can really see the dry line laid out across Texas that she had referred to a little bit earlier in the forecast. I just wanted to point that out of what's kind of going on now that she was talking about in the forecast. Kari, do you have any final thoughts or comments before we have a couple minutes left?
Not really. Oh.
Okay. Last call for questions. I posted the New Orleans sounding from this morning in there too, and you can see how moist it is. So yeah, it kind of gets at the Brad and John's comments about these model soundings tend to be quite dry in the lower levels. It's a pretty common tendency. So yeah, even though this may look a little bit dry, Kari, like if you, well, this is for 15Z, but even putting up the 12Z sounding from this morning, you can see it's, you know, it's a lot more moist in the boundary layer over New Orleans. So, yeah. Okay, I think that's all that I have then if there's no other questions. Appreciate everyone's attention.
All right, thank you, Kari.